Okay, let's do the same with logarithmic functions now. So if we have the parent function y equals log base b of x, notice that we have the transform function where a, if a is negative, it's a reflection over the x-axis. A is also vertical stretch or shrink factor. Remember the h in the inside, left and right, horizontal translation. K on the outside is up and down vertical translation. Recall from section 4.2 that y equals 2 to the x and y equals log base 2 of x are inverse functions. So here I have a sketch of y equals 2 to the x. And remember, inverse functions have swapped x and y values. So for y equals log base 2 of x, instead of having an asymptote at y equals 0, my asymptote will be at x equals 0 right here. Okay, so here's my asymptote, x equals 0. And this point 0, 1 is going to become 1, 0. The original point 1, 2 will become 2, 1. The point 2, 4 becomes 4, 2. 1, 2, 3, 4, 2. Okay, it's going to look something like this. Note that they are symmetrical over the diagonal line y equals x. Okay, so let's take a look at just the graph of the logarithm. What is my asymptote? My asymptote is at x equals 0, right here. My domain is x is greater than 0 because all of my points lie to the right of this vertical line here. It's to the right of x equals 0. The range is all real numbers because the y values are used up from negative infinity to positive infinity. Let's take a look at this example here. Notice that we went right 3, up 1. Okay, and I'm left with y equals log base 2 of x. So note that y equals log base 2 of x looks something like this. But if we graph that exact sketch from right 3, up 1, right, and we just graph it here, this is what our basic sketch looks like. So my asymptote is at x equals 3, because we will move the whole thing right 3. Domain is x is greater than 3, range is all real numbers. Okay, let's go ahead and sketch this. I'm going right 3, up 1, so I'm going right 3, right? The vertical line is going to be my asymptote, up 1. That's just to help me have my new xy axis. So because I took care of the right 3, up 1, I'm really just left with y equals log base 2 of x. So I'm going to find 3 points that will be easy for me, but I'm going to go ahead and rewrite this as log base 2 of x equals y. So I just swapped them. And that's because I think it'll be easier for you to see visually. I'm looking for 2 to the y equals x. So what's like an easy x and y value to plug in? So if I 2 to the 0, right, 2 to the 0 gives me 1. 2 to the 1, right, when y equals 1, I get out 2. When y equals 2, right, 2 squared is 4, so x is equal to 4. Now we can go ahead and plot these points from our shifted xy coordinate plane. So I have 0, 0 right here, 1, 0, 2, 1, 4, 2, that's 1, 2, 3, 4, 2. And I know this is my basic shape, so I can go ahead and connect them all. Alright, so let's take a look at another example here. If I look at the base, it's base 3, so I know my parent function is log base 3 of x. That means the inverse function is y equals 3 to the x, right? The exponential function is the inverse function with the same base. So y equals 3 to the x is the inverse function. Well, y equals 3 to the x is an exponential growth, so I know it looks something like that. And if I make it symmetrical over the diagonal, I know my graph will look something like this guy right here. Okay, keeping that in mind, let's go ahead and find the transformations. I have a vertical stretch by 2, going left 1 and down 4. So if I go left 1, down 4, make that my new xy coordinate plane, and just shift the entire graph over here, right, it's going to look something like that. So my asymptote now is at x equals -1. Domain is x is greater than -1 because all my points lie to the right of the asymptote. range is all real numbers. Okay, let's go ahead and actually plot some points. I'm going to take care of the left one down 4. So left 1 down 4, right? By just shifting the entire origin, the entire xy coordinate plane. So because I took care of the left one down 4, I'm really just left with y equals 2 times log base 3 of x. So the way I'm going to make the table is I'm going to focus on just the y equals log base 3 of x part. So the parent function, the part without the a. And then I'm just going to multiply the whole thing by 2. So if I were to plug in some values again, it might be helpful if you rewrite it this way, right? 3 to the 0 is 1, right? 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9, so 3 squared is 9. So remember, I'm not quite done yet because I have y equals log base 3 of x, but my graph that I need has a vertical stretch by 2. So I need to multiply this whole thing by 2. So y is equal to this whole thing multiplied by 2. So I need to multiply these guys by 2. That gives me 0. 1 times 2 is 2. 2 times 2 is 4. So I made the table again here a little neater. So my x, y points are going to be 1, 0, 3, 2, 9, 4. Okay, so let's go ahead and plot those points on the shifted coordinate plane. Here's my 0, 0. I have 1, 0. 1, 2, 3, 2. And then 9. Right, 9, 4. 1, 2, 3, 4. I know this is what the basic sketch looks like, so I go ahead and connect the dots, and there's my final graph. Okay, go ahead and describe the transformation. So it's going left 2, up 1. Let's think about what this sketch would look like, the basic shape. So if I parse it down to the parent function, this is what I have, which means the inverse function is y equals 1/3 to the x. Remember, the bases stay the same. So this here is an exponential decay graph, so I know it would look something like that. And if I were to sketch the inverse, right, the reflection over the diagonal, it would look something like this. And if we go left 2, up 1, and graph that from there, right, our sketch should be something like this. Go ahead and find the asymptote, domain, and range using the sketch here. The asymptote would be at x equals -2, right here. Domain is x is greater than -2, and range is all real numbers. Go ahead and pause the video and try graphing using 3 points. So if I take care of the left 2, up 1 by creating my new xy coordinate plane right there, I end up with y equals log base 1/3 of x, which is equivalent to this guy here. So 1/3 to the 0 equals 1. 1/3 to the 1 equals 1. 1/3 to the 1 equals 1/3. And then I could put 2, but then I get these fractions, so let's go ahead and try -1. 1/3 to the -1 gives you 3/1, because it's a reciprocal, right? Again, 1/3 to the -1 gives you 3/1, which is just 3. You could have also plugged in -2 if you wanted to, right? 1/3 to the -2, right? 1/3 to the -2 would have given you 3/1 to the +2, which is 9. But again, you just need 3 points. So here I went ahead and plotted all of these points from the shifted xy coordinate plane using this as 0, 0. And now I can go ahead and connect these dots like so. And that is the shape that I was looking for.